estimation of chloride ion in coordination compounds. And this we shall get through an important question which has appeared in different examinations and is therefore a PYQ. Let us view the question. The question is that on treatment of 100 milliliter of 0.1 molar solution of COCl3.6H2O with excess silver nitrate, 1.2 into 10 to the power 22 ions are precipitated. The complex is, and four options are given, and in each option, if you look carefully, you will find that cobalt is the central atom, and the complex has two distinct parts. One is the coordination sphere, which contains ligands, water, aqua ligand, and as well as the chlorido or chloroligand, which is attached to the central portion, central atom in the coordination sphere. And outside the coordination sphere, there is present chloride ion, that is the ionization sphere. And of course, the water molecules are also present outside the coordination sphere depending upon its oxidation state. So we have to find out which of the option is correct. So in such cases, the best strategy is to start with a general structure about such a complex. And we can assume the general structure of this complex as COH2O jet CLX within the coordination sphere and CLY outside the coordination sphere. So this way we find that X are the ligand aqua ligand for chloroatom, chloroligand, and the other for Y is the ionization sphere for chloride. So we can very safely say that X plus Y will be equal to 3 as given in the structure. We find here that is Cl3, COCl3. So that means X plus Y is equal to 3. Now, as I have told you, there is a coordination sphere, there is an ionization sphere in the complex, and this coordination sphere is the non-ionizable part, means the ligand which is present within the coordination sphere, as you can find it within the bracket, it will not react with silver nitrate. Whereas outside the coordination sphere, there is an ionization sphere, and whatever Cl ions are present there, that will definitely react with silver nitrate to form a precipitate of silver chloride. And the remaining part will be left over in the complex. So suppose this is the reaction COCl3.6H2O, then it will react with silver nitrate, will form AgCl, and certain portions of the C chloride ion will be left over within the coordination sphere. Now, if you look at the question again, we find that the number of moles of the complex, it is 100 milliliter, 0.1 m. So we can very easily calculate the moles per liter, and that is equal to 0.01 mole as calculated here. So that's there, and then this is also given that 1.2 into 10 to the power 22 ions are precipitated, ions of silver chloride, silver. Therefore, we can say that if you calculate the number of moles of the precipitated ions precipitated with silver nitrate, ions of course, chloride ions. Chloride ions are precipitated. So here silver nitrate is the reagent which precipitates chloride ions. And we need to calculate the number of moles of the chloride ion which are precipitated. Just divide by the Avogadro's number, that is equal to, you get finally as 0.02 moles. So now we can infer that the value of Y as calculated here is equal to y into 0.01 is equal to 0.02. And we can calculate the value of y this way. This is just a mathematical simplification, and you get the value of y is equal to 2. So we now infer that two chlorine atoms in the solution, that is outside the coordination sphere, has been precipitated and are within the ionization. Outside the coordination sphere, or you can say within the ionization, it's all the same. This points out that the correct formula of the complex should be Cl2, two molecules of two atoms of chloride ions are there. And total number of chlorine atoms given here is Cl3. Naturally, therefore, one Cl is within the coordination sphere. And therefore, the formula of the compound should be CO H2O5 Cl within the coordination sphere and Cl2 dot H2O. That's the correct structure of the coordination compound given here. And if you look here, you will find that the option 4 gives the correct answer. Option 4, that is COH2O5Cl Cl2 dot H2O, is the correct structure. So now it is expected that whatever explanations have been provided to you regarding such type of question would be supportive to you for attempting different such questions and making out the structure of the complex. Please do subscribe to this channel. Thank you very much.